they designed these roller coasters, they use quadratic functions because we're no longer using just straight lines. And if you notice, there's a lot of twists and turns, right? So there's a lot of curves. That's what we're going to be doing now in our graphs, using curves instead of straight lines. So another place that we see quadratic functions are here. Watch. Who's seen theaters that look like this? Anybody seen those? Anybody been to some of these? All right, check this out. Whenever you attend a theater that looks something like this, it's a trip, because even though you're way over here, look up, maybe way over here in the back or on this side, the sound coming from here, the center, it's very clear. And it all has to do with the design of the theater. Does everybody see that, how this curves? Yeah. Yes, and that's what they use. They use quadratic functions to do this design, because quadratic functions have to do with a lot of the designs that involve sound and pitch. And I don't know, also, you guys, who has a dish at your homes? Anybody? Okay, some of us have cable, some of us have dishes. The dishes, when they receive signal, the dish, it's got like a little curve to it, and that's also using quadratic functions. Okay, so check this out. Let me show you the roller coaster. Here's a roller coaster. Here's one type. Here's a curve. Here's another one. And so that you see how this applies to what we're going to be doing today. Today we're going to be graphing. Check this out. Some of you already see it. Some of you don't. Here it goes. So today we're going to be graphing curves that look like that. Okay? Therefore, in your Cornell notes, check this out. That was a quick intro so you get your mind wrapped around that thought. Our objective at the bottom left of your Cornell notes, it says, I can graph a quadratic function and determine whether a point is on the graph of a parabola. So for your objective, I only want you to write, I can graph a quadratic function. What we are going to do is to determine whether a point is on the graph of the parabola. So let's read our objectives together. 1, 2, 3. I can graph a quadratic function. So today we're going to be graphing quadratic functions. So in our Freyer model, what is a quadratic function? Write that in the center, please, of your Freyer model. Here we go. So inside your Freyer model, quadratic function definition. A function in y form in which the highest degree or highest power of the variable is 2. A function in y form in which the highest power of the variable is 2. Quadratic function. Examples. Y equals 2x squared, or f of x equals 2x squared. Next one. Y equals x squared plus 2. F of x equals x squared plus 2. Y equals negative 3x squared plus 1. F of x equals negative 3x squared plus 1. Copy that, and then I'll go over the definition with you guys. According to the definition, let's see, it says, a function in y form. Let's see, are these in y form? Yes, this one is not, but it has f of x, which means function of x. It's the same thing as y. So therefore, it's also in y form. And the highest power of the variable is 2. So look at the variables. What is the highest power? 2. 2, 2, and 2 on all of these, all right? So that's what a quadratic function looks like. Let me show you what does not represent a quadratic function. It says y equals mx plus b, y equals x cubed plus 9, and x squared plus y, x squared equals y plus 5x. Copy that, please. Yeah. It says, we already know what a quadratic function is. So look at these. Why are these not quadratic functions? Think about it. Look at these three. So let's look at the first one, Caden. Why is this not a quadratic function? So do these. Carson. Okay, so all of these have an exponent of 2. This one does not. That's why this is a linear equation, also known as slope-intercept form. You guys remember that one? All right. So look at this one. Turn and tell your neighbor why this is not a quadratic function. Okay? So, Juan, why is this not a quadratic function? It's higher than 2. What is the variable on this one? I mean, what is the exponent? 3. So think about that. If this one has a 2 and it's a quadratic function, this one has a 3 as an exponent, what is this called? Okay? Let's see, I'm going to take you guys back to when we classified polynomials. A polynomial of the second degree was called a quadratic. Remember that? Quadratic, this one's a quadratic monomial, quadratic binomial, and so on and so forth. What would this one be called? It's not a trinomial, I'm saying degree. The degree is 3. Who remembers the degree 3? Cubic function. This is a cubic function. That is correct. Agree with me? All right, look at this last non-example. Why is that not a quadratic function? So look at the definition and look at this one. Talk it over with your neighbor. Why is this not a quadratic function? Okay, so you volunteer for this one. Bailey. It's not in Y form. That is correct. So what has to happen in order for it to be a quadratic function, everyone? Subtract the Y or bring all this over here. All right, so what is the most important thing to remember about quadratic functions? That they need to be in what? And what else? Highest degree is 2. So those two things, write them down. Y form and highest power is 2. That's our critical attributes. Pause it. Take a little break. Yeah. Yeah. Okay, everybody got it? Yes. Steps, write these steps down, please. Actually, before I move on, look up. It says, which of the following is an example of quadratic function? Tell your neighbor which one of these is a quadratic function. Very good. Nice way to tell your neighbor. It's B. You got it right. All right. All right, let me get someone to help me out for the answer on this one. And the question is, in your own words, what is a quadratic function? Let's see. How about definition of quadratic function in your own words? Go, Joel. In your own words, what was the main thing to remember? It's always in Y form, and what else? Highest exponent is 2. Does everybody agree with that? Yeah, we got that. All right, thank you. So write these steps down. Steps. Step 1, make sure the function is in Y form, open parentheses, solve for Y. Step 2, build an input-output table and add a domain of -2 to 2. Step 3, substitute the values into the function and find the range. Step 4, plot order pairs and graph the function. Step 5, check if the given point is in the function by substituting. Copy those 5 steps. Then we'll go over one example together. To copy. So I included in your notes, turn your paper over really quick. I included a graph paper in the back. So on the top right, copy this, example 1. It says graph y equals 2x squared and check if 2, 1 is on the function. I'm sorry? Do I record? Oh, yeah. Yeah. At the top top right, you're going to copy number 1, graph y equals 2x squared, and check if 2, 1 is on the function. So this is going to go pretty quick, so stay with me. Here we go. Step 1 says make sure it's in y form. Is it in y form? Yes, so step 1 is done. How about step 2? Build an input-output table. Do we know how to do that? Yes, so write x, y, and our domain is from -2 all the way to 2. Write that in there, please. -2, -1, 0, 1, and 2. From there, we need to substitute values into the function so that we can get our range. So rewrite this function, write y equals, but instead of the x, you're going to open up parentheses. So y equals 2 times whatever squared. So what is our first value? -2. So we're going to write that in here. -2 goes in here. So -2 squared is -2 times -2. Is that correct? So what is -2 times -2? 4. So we got y equals 2 times 4. What is 2 times 4? 8. So therefore, 8 goes right there. Okay, what is -2 squared? 4. What is 4 times 2? 8. So let's plot this point. -2, 8. Plot it on your graph, please. And if you can get that up close, -2, 8, -2, 8 is about right there. And write your ordered pair. So we got the first value. What will be our next value to substitute in here? -1. So we bring -1 in here, rewrite it again. So let's see. What is -1 squared? -1 times -1 is 1. So we end up with y equals 2 times 1. What is 2 times 1? 2. 2 times 1 is 2. So that goes here. So therefore, let's plot this point. -1, 2. -1, 2 goes right here. And write your ordered pair next to it. Everybody see that? Okay. See if you can fill out the rest by yourself, but see if you can do mental math for these. So let's see. What would be the next value that goes in here?
0. So 0.
0. So 0. What is 0 times 2?
0.
So that is 0 goes here. That is correct. And that is our point of origin. It goes right there. Write it out. And see if you can finish the rest by yourself, please. Yeah, you can go. Here we go. Bye. So who got, what is our y value when x is 1? 2 is correct. So that goes right there, and our point is 1, 2, which is right here. And the last one, who got the last one?
8.
Which is? 8. That is correct. That goes right there, and the point is up here. So now check this out. Like I said with roller coasters, we no longer have straight lines. Now we're going to have curves. Now this is how you graph these, so pay attention. Pens down, eyes up here. Here it goes. Just like every graph that we graphed in the past using the slope, we're going to graph this starting from the point farthest to the left, because we're reading it from left to right, and that's how you're going to connect all those points. So which is the point farthest to the left? -2 and 8. Which is the second farthest? -1, 2, and then from there 0, 0, 1, 2, and 2, 8. And that's how you're going to start. You're going to start from here and go in that direction. So this is how you go. You start from here, go down, and bring it back up, and that's how you sketch your parabola. That's what it's called, a parabola. And once again, this is a quadratic function, parabola. But check this out. It says, check to see that if 2, 1 is on the function. So first let's plot it to see if it's on the function. 0.21 is right here. 2, 1. Is that on that function?
No.
No. This person's off the roller coaster, so they're over here. Ah, there it is. So they didn't make it on the roller coaster. So they're not on the function. Another way of checking this, we already did in the past, check this out, is by substituting these values into the function. Which one is x? Which one is y? So you get this equation, and instead of y, we put 1. Instead of x, we put 2. So this becomes 1 equals 2 times 4, and 1 equals 8. Is that true? No, and that's how we find out if that's part of the function. Everybody see that? All right. So pretty much if we graph, we're going to continue doing that. So let me show you at the end what it's going to look like, all of the different graphs if we were to graph these. Check this out. Look up, please. Look up, please, so you can see the patterns. Here it goes. We're almost done. Look up. We just graphed this one. Look at the coefficient and look at the graph. Pay attention, please. If we were to graph this one, look at the coefficient and look at the graph. Look at the coefficient, look at the graph, and look at the coefficient, look at the graph. So, what can we conclude? If it's a positive coefficient, it goes what? So what? If it's a positive, just remember it makes a happy face. If it's a negative, it makes a sad face. And we'll talk about the other characteristics later. Have a good one, guys. Enjoy your free home play. Enjoy the fair. See you guys till Monday. Bye.